Greetings of the day. Welcome to our channel again. Welcome to the continuation of the part one. In part two, we're going to see about the strain. What is strain? Strain is a measure of a deformation representing the displacement between the particles in the body relative to a reference length. Ratio of the change in the length due to the deformation to the original length. It's basically the change of the length. It is a dimensionless quantity. Numerical values of strain are usually very small, especially for structural materials, which ordinarily undergo only a small changes in the dimension. Types of strain. Normally, we can observe or we can identify the normal strain. The normal strain is a deformation of a body which involves the elongation or the contraction, which I said before. The change in dimension is actually the elongation or the contraction. When a bar of a length L and a cross-section area A is subjected to the axial tensile force, which is P through the cross-sectional centroid and the bar elongated, the change in the length divided by the initial length, which is the bar's engineering strain. The symbol for the strain is epsilon, which is look like a capital E with a curve. The strain is actually loaded bar is, if you observe, this is the length, this is the original length, and this is the area of a circle, and this elongation part, which refers to the change in the dimension. Some the elongation part maybe is elongation or maybe it's contraction in any other situation. So the formula is epsilon is equals to the change over the original length. Shear strain. Shear strain is a strain which involves a shear deformation, such as like body twist due to the torsion and a distorted cuboid as shown in figure 1.8. Strain change the angles of an object and shear cause the line to rotate. In this kind of situation, we will further see in a more like a structure of mechanicals in part two of this chapter. Why? If you see carefully, this is the total length and it was the angle and the original length and the duplicate and also the torsion there. Example number one. The joint is fastened using two bolts as shown in the figure below. Determine the required diameter of the bolts if the allowable shear stress for the bolts is 110 megapascal. The question asking the required diameter of the bolts. Okay, let's analyze the diagram. As you've seen, there's a two bolts are there. At right side, it shows 60 kilonewton and the left side have a two bars which shows 30 kilonewton respectively. So how to solve it? Yes, by coming up the formula, the double shear connection is for tau is a P over 2A, where our area is a pi d square over 4. Since using two bolts, we times the 2A times 2 becomes P over 4A. When we got the A area value and the P value, we can identify by using the diameter. As we solve this equation, we got the diameter 0.013 meter. Okay, this is a very interesting and challenging one. Every engineering student should understand this relationship, the relationship between the stress and the strain. The relationship between the stress and the strain we can identify by using this graph. This graph shows very clearly how to identify the relationship between both of these. Our y-axis is state stress and our x-axis is state strain. Our curve or our graph is simply will look like this, where at this certain of the point until the point of ultimate strength, it shows strain hardening, and after ultimate strength to the fracture, it shows the necking. By the first step, it will go very steep until the yield strength and a go down and an upper curve until to the ultimate strength. To find the Young modulus, we're using the slope method, which is the rise over the run. Elastic proportional limit by using the terms of the Hooke's law. From the origin O to the point called proportional limit, the stress strain curve is straight line. The material will return to its original position. Elastic limit is the limit beyond which the material will no longer will go back to the original shape when the load is removed, or its maximum stress that may be developed such that there is no permanent or residual deformation when the load is entirely removed. What is yield point or yield strength is the point where the material will have an appreciable elongation or yielding without any increase in the load. It says is undergo the plastic deformation. At the part of the straight hardening is the point C to the D. It's called as straight hardening part, where the curve rises gradually until it flattens at D. The stress which corresponds to the point D is called the ultimate strength or ultimate stress. Ultimate stress or stress is the ultimate stress or the tensile strength, which is the maximum ordinate in the stress strain diagram. Rupture strength, or they call as fracture, is a strength the material of the rupture. It's also known as a breaking strength, or which we understood in a common way was the final point. Offset method. This offset method is very important to person to identify and draw the stress strain graph. Besides steel, other materials such as aluminum, glass, brass, and zinc, constant yielding will occur beyond the elastic range. This metal often does not have a wide defined yield point. Therefore, the standard practice to define yield strength is for metal is a graphical procedure called as an offset method. Normally or strictly 0.2% or 0.002 mm or mm is chosen from this point from the same absolute axis to the parallel to the initial straight line portion in the same stress strain diagram is shown. As you see, this is shear and strain here, where from the initial point, from the zero, we will take a note of 0.002 and we take the offset method. How to take this offset method? Yes, we should need a ruler. We're taking this ruler by taking the original shape of the graph in the beginning. In the beginning, as we say, with this will be a straight line, we can measure the slope also by Young modulus. So by using this line, we are offset to 0.02 and we're taking the value of at the graph which touch the stress. Let's see one example so that you can understand more about it. A rod with diameter of 5 mm and the length of 100 mm is stressed slowly with a load up to the failure. This result for the test shown in the table E1.8. Draw the stress strain curve and determine the modulus of elastic, yield stress, and the stress maximum, given the force value and the elongation value. When they given the force value in Newton, the elongation value in millimeter, what's the next step? Yes, the next step by using the formula of strain and stress, use the formula and identify the values. When you identify all the values, you normally will get 1 or 2 marks, depends on the schema. After we get all this point, we should plot. Yes, the second step is we need to plot by using the values of strain and stress. When we plot, we get the curve very nicely. If you observe my cursor here, this is the curve and this is the shape of the graph. To find the modulus, we using the formula of slope. So at the first part, which was the straight line rising up, we're using the formula of the slope and get the value for the modulus. Second, what the question was asking? The question asking for yield stress. The yield stress is very easy to determine. As I told you, we using the modulus method. By using the modulus method, we're using the offset method. Very sorry. We're using the offset method. As we know, we can use measure 0.2 from the initial and draw offset line, and the cross section will show you the value of the yield stress. And the last is the shear maximum. The shear maximum we easily can identify by the graph. The top notch or the maximum point of the graph will be identify the shear maximum. I hope this topic will be easier for you when you do it. So everyone try to do this question